Hello friends, today I am going to solve LeetCode problem number 33, search in rotated sorted array. In this problem we are given an array sorted in ascending order. Each of the elements are distinct and this array could possibly be rotated at an unknown pivot index. And also we are given an integer target. We need to find the index of the target and return it in the nums array. If not, we are going to return -1 and we are going to solve it in logarithmic time complexity. So let's look at this example over here. So if we were to apply brute force solution, then what would be the time complexity? In case of brute force, we will check each of the elements with the target value, right? So it's not equal, we will keep iterating until we found the value. So in that case, the worst case complexity will be O of n. But we are not going to use brute force, we are going to use binary search, which will allow us to solve this problem in logarithmic time complexity. But how are we going to use binary search? Because we are given that this array has been rotated from an unknown pivot point, right? So if we look at this array, we have these elements which are in ascending order, and then we go back to 0. 0 is less than 7, so basically now it has decreased, and now starting from 0 we again have an ascending value, right? And since this is rotated, if it were not rotated, this whole chunk of values should be before the first element if it was not rotated. So without rotation, this array would look something like this. So we would have 0 1 2 4 5 6 and 7 if this was not a rotated array. Now since this is a rotated array, we have two different sections, right? This is also ascending order, this is also in ascending order, and this whole thing is in ascending order. And since we have two different sections of these, we can divide it into two halves, right? And if we divide it into two halves, and if we know where this thing is being divided, we can actually solve it using binary search. Okay, so what are we going to do is we are going to find the point where it has been rotated from. Okay, so if we know the index of this element, that is the 0th element, then we can perform our binary search. So let's suppose that now we have found the index. So we'll find the index also by using binary search only. So once we have found the index, what are we now going to do is, given the target, we are going to compare it with our last element, or we can also compare it with our first element. So let's just compare it with our first element. So our target value is 0, which is less than our first element. Since it is less than first element, that would basically mean that that would basically mean our first element less than first element, right? So that would basically mean that in ascending order it should lie towards the left, and since it is rotated, so all the values towards the left are after the pivot, right, after this index, right? So what are we going to do is we are not only going to check this search space, and within this search space we are going to perform binary search, because this is now a complete ascending order, right? If in case our target value was equals to 7, in that case we compare it with the first element, which is 4. Since it is greater means it will lie after this value, right? But it will be before the pivot, because this is the first element, so this is definitely less. So we will take this chunk starting from the first and until the pivot point, and only perform our binary search in this section. So in that way we are able to solve it using binary search. Now we are going to see another approach to solve this problem, that is by without finding the pivot element and just performing binary search in one go. Okay, so for that, as I already told, if we are able to find the point where it has been divided, we actually are able to find which section to search, right? So using the similar concept, but we are only going to do it with middle value. So what we do is we find our middle value, which is this value here, and now we check our middle value with the first element. Since middle value is greater than the first element, Now what we need to do is we need to find if the target lies uh within these range, right? Because middle value is greater, so greater means of course uh there is a range between these, right? I mean, middle value is greater means it lies after this value, of course. So if our target lies within this range, then we are only going to search, and this is search space. Okay. So now since our middle value lies between greater, but our target doesn't lie in this search space, so what do is we go towards the right side. So now our search space is this much, and in this case also we do the same thing again. We check the middle value. So our middle value is 1. Now our left pointer is this one, our right is this one, right? So we check the left and the middle value, and left is less than middle value is greater than left. So now we check if the target lies within this range. Yes, it lies within this range, right? It is greater than equals to left and less than the middle value. Now what we do is we shift towards that section. So basically now we are performing binary search, so we only check over this section, and then since this is left and right, middle value also lies in this portion and it is equals to our target, we found our solution. So basically that is what we are going to do. Now let's suppose this was equals to -1. Okay, if this were equals to -1 and our target is equals to 0, now we check our middle value, which is this value -1, and our left value is 4. So -1 is less than 4, right? So in that case, now what we do is we compare our target value with the right hand side value, and since our target value, if our target value lies with is less than the right hand side and is greater than the middle value, that means our target lies within this range and we perform our binary search in this portion. If not, we perform our binary search in the rest of the portion. So basically this is the idea behind our solution. Now I hope that you have got a grasp of it. If not, I'm also going to explain it while coding. So let's get into coding. So what do we need is, first of all, let us get the length of our array. Now let us define the left, which is equals to 0, right pointer, which is the last index, and mid. Okay, and while left is less than equals to right, okay, left rigst, okay, left is less than right, we are going to find mid. So mid is math dot floor value of left plus right divide by 2. Okay, now we need to check if target is equals to the value at mid, that means that we have found our target and we are going to return the index, which is mid. And if not, we actually return -1 if we are not able to find our target at all. Now if in case target is not equals to the middle value, then what do we need to check? Where does the target lie? Does the target lie in this range or in the other range? So we need to first of all check the middle value with our first element, right? So if middle value is greater than left element, so if nums mid is greater than or equals to nums at left, so that is when we need to check, since mid is greater than this one, so we check if our value lies in this range, right? So if, now this would be else if, so if our target is greater than or equals to nums at left and target is less than nums at the mid portion, then what we do is we search and this is space, right? So we are moving our right pointer to mid plus 1. So right is equals to mid plus 1. Else we search the rest of the portion, right? Rest of the array. So that would be left would move to mid plus 1. Okay, so this will be mid minus 1, else left equals mid plus 1. All right, else if nums at mid is less than or equals to nums towards the right, that means if this was a minus 1, so that in that case basically we don't need an if, because this is generally if this was not greater than equals to, then that would be less than mid, less than the left, so basically less than equals to this value, right? So we do not need the if statement condition. So now if in case it was this condition, so what we need is now we need to check if it lies within this range, and since this is an order, right, ascending order, we need to check if it lies in this range, the target. So if target is greater than nums mid and target is less than equal to nums at our right, so if that is the case, then what do we do? If our target lies within this range, so our left pointer is shifted, right? So our left will be equals to mid plus 1, else we check the rest part, so our right is mid minus 1. Okay, so this is the algorithm. Now let's try to run this code. Awesome, it worked. Submit this now. Great. So basically this is how we are going to solve it in one go. So what we did here is, if we found our target, which is return the middle value. If not, we are checking, like we need to know basically a sub array which is in complete ascending order. So if mid value is greater than left, which means that starting from left to the middle value, it's a complete ascending order. So within this order, if our target falls within that order, that would mean we need to shift towards the left. So our right is now shifted, right pointer is shifted towards left, else we shift our left pointer towards the right, and so on. Similarly, if our middle value was not, greater than left, so that would mean that rest of the section is in ascending order, and in that case, we in this section which is in ascending order, now we need to find if target lies within this section, then our left should be increased, right? So left should move towards the right hand side, else right moves towards the left hand side, and that is how we solve it. So I hope you liked my solution, and let me know in the comments down below. Thank you.